Now we take the second method of factorizing a quadratic equation. Now if you have a look at this equation is not factorizable if we split the middle term in such a manner that the factors of 1 should give you 3. Factors of 1 are 1 into 1. You do not get 3. So what we do here is we transfer the last term to the right hand side. Okay, this last term we are going to transfer it to the right hand side, so that becomes minus 1. Now what we have to do is we have to make this left hand side of the equation a perfect square. To make it a perfect square, we will make use of the formula third term is equal to half into coefficient of x whole square. What is the formula to find out the last term? Half into coefficient of x. This is x. Its coefficient is 3. So half into coefficient of x whole square. So let us go for that. Half into 3 whole square. So that will give you 3 upon 2 whole square, which is nothing but 9 upon 4. Okay. What is 3 upon 2 whole square? It will be 9 upon 4. Now what to do with this 9 upon 4? We will add this 9 upon 4 to this equation. So what do we write? Adding 9 upon 4 to both sides of the above equation. Okay. So when we are adding 9 upon 4 over here, we will get this equation as x square plus 3x plus adding. We are adding, so plus 9 upon 4 is equal to minus 1 as it is. And what do we have to add here also? 9 upon 4. Okay. Now this becomes a perfect square. A perfect square of x plus 3 upon 2 whole square. See, square root of the first term. Square root of the first term is x. Sine of the middle term and square root of the last term. 3 square root of 9 is 3 and square root of 4 is 2 whole square. If you multiply this 2 times, you will get this answer, children. Okay. Now here we will have to go for cross multiplication because the denominators are unlike. So that will give you minus 4 plus 9 upon 4. So here we get x plus 3 upon 2 whole square, which is equal to 5 upon 4. Minus into plus is minus. You will subtract, but sign of the greater number. So 5 upon 4. Now what we do is we have to find out the value of this x. So we need to remove this 3 upon 2 from here. Before that, we'll have to remove this square also. So for that purpose, what we do is we take square root of both the sides. Taking square root of both sides. So you will get x plus 3 upon 2. Square root of this number will give you x plus 3 upon 2. And here you will get 2 roots of 5 upon 4. So square root of 5 is root 5 only, and that of 4 will be 2. So plus of minus root of 5 upon 2 you will get. Okay. Now as I said, we need to find out the value of this x. That is the roots. So x will be equal to, we'll have to transfer this term. Okay. So this plus will become minus 3 upon 2 plus of minus root 5 upon 2. Your denominators are like. So you can add or subtract the numerator. So you will get the roots of this quadratic equation as x will be equal to minus 3 upon 2 plus root 5 upon 2, or x will be equal to minus 3 upon 2 minus root 5 upon 2. So that makes x is equal to minus 3 plus root 5 upon 2, or x will be equal to minus 3 minus root 5 upon 2. So these are the roots of the quadratic equation which could not be factorized by simple method. This method we call it as completing the square method. There is one more type of sum for completion of the square method. We'll do it in the next video. Kindly subscribe to my channel please, and if you have any queries, put it in the comment box. Thank you.